Everybody just setting up here. I will let a few people come on before we get going here. And I will get this link out so people can know that the live stream is going here. And there we go. There's the tweet. And if anybody's there, let me know. See if this is working here. Can you guys hear me? There we go. Good evening, everybody. 5x5. All right, good to hear. I haven't looked at the 00Z GFS yet, so we'll do that live real time too. The Euro will start running in about another hour. Keith Evans, member Keith Evans. How's it going? Sean O is a member. All right, so we're getting some people in here already. It's going to look a bit at that. Let's look at the 18Z Euro here real quick first. Just kind of compare that to its earlier run. Man, the Euro sure took a turn for the worse this morning, didn't it? It just... That's what I kind of worry about with these events. Sometimes they just, you know, that zonal flow just pops in there. All right, thanks, Kevin Moore. Thanks for the support. Sometimes those polar lobes just get out over the water too much, or these ridges don't form correctly, and it can put an end to your Arctic hopes in a hurry, like the European did there this morning. GFS is still sticking with it, and the European still actually had a pretty interesting system coming through. So not all is lost, and it just might be a delayed thing where we get snow later on into February a little bit, maybe just after the 10th or February 9th, somewhere around there, where we have another chance at some cold air getting in here. But oh, can you guys hear me? Okay. Oh, I saw somebody saying I might be muted, but looks like it's okay. I heard somebody say they had me 5x5 there. Five by five. Okay, we're on. Okay. Thanks, Kevin. Thanks for the support. Nope, no problem. All right, so let's look at the 18Z. There's still some interesting storms that might develop out of this pattern too. No, there could be some interesting systems coming out of this. It might be pushed back a bit, and we're going to take a look at that right now. We're going to watch the GFS. It just came in, and then we're going to do the European here, 12Z versus the 18Z. 12Z is on the left, 18Z is on the right here. And you can see pretty good agreement here through about hour 108. And then you can see the system finally start to get in here. I mean, we're finally going to break this fog up. So this is about as far as the European control goes. And pretty good agreement, really, run to run here. You get the Arctic air, the gradient you can see at the Arctic boundary is here up through northern British Columbia. And you can see that Arctic high over here. And it's kind of on the east side of the Rockies. There's a bit of Arctic air there. This system is a chilly one, but we're on the warm side of it. So we're going to get some decent rainfall here. And actually, let's go ahead and let's do this really quick too, because I saw a little bit of a hint at an atmospheric river here. So let's see what kind of precip is coming here. It just starts there at the end of this run. So we'll look at that potential on the GFS here coming up. We just started the live stream, guys. Yeah, man, those wind chill factors out there in North Dakota, Minnesota are just crazy. They've been having some really cold temperatures recently. Yeah, there might be a little bit of east wind coming in here. We can look at that actually briefly too before we jump right into the GFS. Let's look at that real quick here. Actually, let's do that with the NAM 3 cam because we'll have the 0Z should be in here. Let's go to Washington. We can see Oregon on this too, and we will look at surface wind and look at wind speed here. You can see we've got this east winds coming up later. Let's check what it's going to do. When do these pick up here? You can see them pick up through the gorge here a bit tonight. So some areas of Portland might be getting cleared out of it. There's actually some wind coming through the Stampede Gap here. There's an area just north of Mount Rainier, and this is the one that actually plagues Enumclaw with the strong east winds, that Stampede Gap here. And some of those winds look like they're going. Let's check what the miles per hour are through here. I mean, yeah, there's some 35 mile per hour gusts coming through the Stampede Gap. I wish that would translate, but look, it's not really translating out to Seattle and Tacoma. I mean, it really stagnant again tonight. And then the winds died down into tomorrow afternoon. Look at the gorge winds. There's a narrow band of gorge winds there. So anybody here down in Portland, you can see some of this coming through the gaps here on the coastal range there in Oregon too. So it should keep the fog stirred up. And this hasn't been really a problem there on the Oregon coast. So looking into the future a little bit more here. This is Wednesday morning. Still really stagnant. I mean, still the gorge winds are going here, and there's a little bit of offshore flow going out here. Aberdeen, Willapa Bay, and the Stampede Gap winds pick up a little bit again, but just no rest for the weary here. This is just, these visibility values have just been miserable, and as you can see here, let's look at tomorrow morning here real quick. Look at that fog just set in the Puget Sound, and you can see where those gorge winds are just kind of clearing that out and keep that visibility pretty decent there for areas of Portland. And of course the Oregon coast, Washington coast should be pretty good tomorrow. Yeah, Seaside sounds like it's been a nice place to be the last few days here. At least you're not in the soup here. And Daniel Whitaker says Cap kept the fog in the valley all day yesterday and today, cold just south of Salem. Okay, so let's go ahead and, yeah, that is pretty socked in down there. It looks like you guys might break out a little bit tomorrow. The Puget Sound stays pretty socked in, and so does, man, look at the strait up just north of the San Juans there, Vancouver, over the water, the Strait of Juan de Fuca, just really socked in. Then you can see it build back again. Tomorrow night looks ugly. I mean, look at some of these visibility values in the Puget Sound. The Willamette Valley better than the Puget Sound tomorrow or Wednesday morning. Yeah, you guys are lucky out there on the Oregon coast. I'm jealous of your guys' sunshine there. And look at that Wednesday morning, man. That fog finally burns off a little bit going into Wednesday afternoon, but you can see it really never leaves the Puget Sound there and the Strait of Juan de Fuca and the Georgia Strait up there. Whidbey Island never gets out of it. And then you see back into Thursday morning, back into the dense fog for Puget Sound. So, yeah, Debbie Nelson says yuck. And I don't mind a couple days of fog, but, you know, it starts getting old after about the third day, kind of like rotten fish. All right, let's do one more thing here before we go look at the GFS, the brand new GFS that just came in. So this is tomorrow morning. Looks like maybe a little bit of freezing fog, especially up towards Vancouver or Bellingham. Yeah, the Willamette Valley, watch out for freezing fog tomorrow too. And of course, eastern portions of the states, watch out over there. Stays cold all the way through tomorrow. Not even really getting to maybe 40 degrees tomorrow. And it cools back down again, and there's gonna be some freezing fog in the Puget Sound on Wednesday morning, so that's gonna have to be watched too. Aaron Green is here. Remember Aaron Green? Yeah, get some elevation. I mean, look at this. It's unusual that you see the mountains so warm here and the Puget Sound and the Willamette Valley so cold. The strength of this inversion is just uncanny. Eastern Washington, you can see it, the inversion into the valleys. And just in the mountains, it's much warmer. You go into the afternoon, and there's some, you know, you're getting up towards 50 degrees here, up in the 50s up here in some of the elevations just east of Portland to Seattle. Look at the Oregon coast, nice and warm. Mid-50s again in Seaside. 34 all day in Lake Stevens. Yeah, that's tough. Okay, so I have not looked at the GFS yet, and I've got it all set up here. We're going to compare the 0Z versus the 18Z, as you can see. This is the North Pole. You can see North America in here. Here's our big ridge. It's just giving us our super stagnant air. And what we're watching is this ridge out here. How does this ridge develop? You know, the models were showing that, steering some cold air in, and now they're changing their mind a bit. But it was still kind of close on the 18Z Euro. We'll see what it trends to now. So as we go into the future here, still have the ridge over us, and this is on the 28th, the morning. And finally on the night of the 28th, the 29th, and the 30th, not till the 30th. So on the 30th, looks like that system breaks down. You can see still pretty decent agreement, really. Well, the ridge is even closer on the 0Z here. The ridge was a little bit further west on the 18Z. So this system right here might be kind of interesting. It could be still kind of fun. You see this ridge is steering this system here, and this is going to be a pretty strong system. And I like the trajectory on that because that could bring some kind of vigorous convergence zone there too. Kevin Hendrickson, welcome to channel support. All right, thanks a lot. Thanks for supporting the page. And let's see. Okay, so yeah, I mean, we're going to have more chances in February. There's a, you know, this ridge out here is the signature we need to get cold air into the area. And this looks a little bit, I like the look of this system here. This is going to bring possibly, you know, definitely really good mountain snows. And it might bring a cool convergence zone. There might be some thunderstorm activity with it, some small hail. A system like this can be pretty interesting. And then you'll see this, you know, this really cold air at 18,000 feet just dive all the way down into Southern California. That would bring a really powerful storm all the way down to the Southwest U.S., which would be kind of interesting to watch too. And now we're starting to get some disagreement here. You can see how the ridge is stronger on this recent run here versus a little bit weaker here. And this really cuts off. Look at how the cold air on the 18Z really was down into the lower 48 here. And now the GFS really cuts that off again here. And it really gives this bigger system down into the Southwest US versus the 18Z, which swung this lobe, this polar lobe through much quicker. And I believe, so this is the storm that's going to hit the East Coast here. I'm getting ahead of myself a little bit. So the models are in pretty good agreement at this next one. This nor'easter coming up the East Coast here. That's going to be a headline maker right there. I mean, that's going to really pound some areas there on the East Coast. Okay, then our system moves down and it hits us and it starts diving down to the southwest here. Polar lobe up over the polar North Pole here. And then we've got this next system that's going to try to break down the ridge here. Or the European was showing this next system breaking down our ridge. And you can see how that this gets more cut off here versus the 18Z where it swings it through and it's more progressive, and it would have brought another storm to the East Coast. It slows it down a bit here. And this would be another interesting system here. So this run is, you know, this run isn't bad. Both the 18Z has a version of that riding the top of the ridge, and this one also has it riding the top of the ridge, but a little bit, I like the one on the 0Z better, but we're getting kind of far out here now on the GFS. But this system is definitely worth watching. This is going to be a fun system. This one that moves down on about the 31st. So the last day of January, that system right here is going to be pretty interesting. So let's go ahead and zoom in a little bit on this now. Let's get a little more detail. What's the yellow and the blue blobs? That's even more cold air, really. This is showing just how abnormal the anomaly, basically. The anomaly at 18,000 feet. That yellowish color inside the blue there means quite a bit colder than normal. And if we can look at, let's see, I'll show you the 700 millibar temperatures there. So this is the system kind of sliding down here. You can see this lobe of cold air here. That's going to be the system for the 31st. Models are in pretty good agreement about bringing that down. And you can see it throws a good chunk of cold air down over the Pacific Northwest. And you can see that dive all the way down into the southwest there. It would bring a pretty good system down into Southern California, probably areas of Nevada and Arizona. And then you can see the next system that would slide by on the 4th or the 5th of February there. And then we'd be waiting to see if any more of this cold air got down into our region on into the extended, which it does a bit here, but this is way too far out on the GFS to be getting into at this point. So we're looking at the one on the 31st right here, this cold air that's moving over now. And if we look at the 850 millibar anomaly, that's 5,000 feet. You can see we've got some areas of pretty chilly air, abnormally cold air moving down. But you can see the really good Arctic air is mostly east of the Rockies here. And we're going to zoom in a bit and take a look at that closer. You can see it's on the east side of the Rockies here. It's chilly air, but it's not true Arctic air here that's getting down on us. Well, one of these systems moving out of the north, Soup Films asked any possible snow for Portland soon, and it's possible, but there's going to be a lot of onshore flow with this system. But then there may be the upper level low may transfer right over us here, and it might bring the snow levels down lower. It looks like it tries to get some lower snow levels through there in Oregon, but it's still too early to make a call on if that's going to be snowfall or not. It's going to be an interesting system. There can be convergent bands behind this as this moves south. Something I like to look, a system, a quick hitter like this that moves through, I like to look and see if well, we're going to have to zoom in a little bit more there because that's not going to work. I like to look at areas of Cape too, because these kind of systems that move out of the north like that is going to give a nice trajectory for a convergence zone of the Puget Sound. And as that moves through, you can see there's quite a bit of convective available potential energy. So there could be a snow level brought down in any areas of convergence when you have that much instability going on. So that's a possibility there. And as we let's look at surface wind and just kind of see the wind pattern at what it's bringing us here. So you can see we've got all onshore flow here all the way up through BC. No true Arctic air danger here. But as this system moves by, you can see we get a wind shift there to the north. So you're getting northerly winds through British Columbia here. It's a very modified Arctic front. And then it pulls down through the Puget Sound here. So there's probably going to be a nice convergence zone that would move through here at this point. But again, it might just be convective, and it might be, spotty snow showers or some small hail, or maybe even a couple lightning strikes. But it might be a nice little system to have go through here. And plus, it'd clean out the air quite a bit. A lot of mountain snow, for example. Yeah, Aaron Green asks, the big systems moving south can drag cold air behind it into our area. Well, yes, and when you get the interactions with the terrain, like the Vancouver Island, you can get convergent zones as the winds wrap around it. And then when you get that convergent zone, you can tap colder air aloft better. So if the air is chilly enough at 5,000 feet or 2,500 feet and you get convective showers, you can tap that easily. You can bring the snow level down to the surface. You're not talking a true Arctic outbreak where you're going to have frozen streets or anything, but you can get, a convergent zone band that drops an inch or two of snow in systems like this in the lowlands. It's not out of the question. And there's a lot of interaction with the terrain and a lot of cold air aloft. You can get those convergent zone bands all the way down, through Seattle towards Tacoma. And when there's enough cold air offshore and it's streaming in, it's convective, you can get that snow level down even to the surface in the Willamette Valley briefly. It's not like we're looking at a big Arctic freeze, though, at this point. Isn't the Will Parnell asks, isn't the ensemble run better to use as a guide generally after about 5 to 7 days to forecast a general pattern? Yes, it is. When you're looking at a general pattern, you kind of want to know what's happening. You're definitely better off looking at an ensemble mean. The only problem with ensembles really is if you're dealing with Arctic air in the Pacific Northwest and you've got Arctic air to the north, usually the ensemble is going to show a multitude of different possibilities. And some of those possibilities are onshore flow and warmer. Some of those possibilities are Arctic air getting into the region. So when you look at an ensemble mean, it's just taking an average of those temperatures. And so it's not really telling you much because, anybody can just add up numbers and tell you what an average is. You want to know what are the odds of that Arctic air getting into the region. So sometimes ensemble members are more valuable than at other times. Because you can just kind of say, hey, it's going to be 38 degrees. I'm looking at the ensemble mean, it's going to be 38 degrees and it's going to be raining. It's like, well, half the ensemble members are bringing Arctic air into the region. That's not a very helpful forecast. You need a more specific forecast. So ensembles are great for, certain applications, but they're not always so helpful. Soup Films, did you go to school for weather? Yes, I did. I went to a technical college in Montana too. I also went to Green River. I took a lot of aviation classes there, a lot of aviation weather classes, a lot of air traffic control classes. Yeah, we can look at the Canadian also. That's a good idea. So let's look at the Canadian run next year too. And let's compare it versus its run this morning, if it will allow us. Sometimes this thing gets there it goes. And we'll do, actually, let's back out here a bit and we'll go to, and we'll compare this is the Canadian model. We're comparing it to its morning run here. This is this evening's. So what we're looking at here is basically these are, you can call these a reflection of the polar vortex, or I feel more comfortable calling them polar lobes. I don't like just pointing at this saying, hey, this is the polar vortex, yada, yada, yada. The polar vortex is a very dynamic system, and it goes well into the stratosphere, many miles up, and it has delayed lag time on what occurs at the lower levels of the atmosphere. So I've started leaning towards calling these polar lobes, basically. This is more Arctic air. Once you get above the green here, the air tends to be colder aloft. And when you're looking at these gradients, this is surface. These are surface pressures underneath, and this is 500 millibar heights above that. So it's an effective map where it's showing you what the temperatures are at 18,000 feet and what the surface pressure map is at the same time. So putting this into motion here, you see this polar lobe just kind of swinging, and the Canadian is not liking this. We might just leave that alone and just look at the run itself. And you can see this polar lobe kind of swinging down here, and this is going to be the big storm here. You can see how this nice cold air has gotten all the way down into the southern states here, and this low is going to feed off this warmer water offshore here in this tight gradient, big snowfall amounts possible for the East Coast. So a nice storm for them out there. And you can see we're kind of still going on in the ridge here. We're in the January 29th, the morning here. But here comes our system here. It's a bit colder. Arctic air is still locked up north. And as you see this start to march down, you can see that Arctic high. And here's the Arctic boundary well up here in the North British Columbia. So no threat to us now. But you can kind of see the system move through, and there's a possibility with convergent zone bands with this system. And then you can see this drop down its cold air. And it's different than the GFS, for example. It brings its cold air a little more progressive out into the Rockies here. But you can also see later in the Canadian, this is kind of interesting too. This polar lobe here is more of a threat to us, actually. So we may not be out of the Arctic air possibilities. They may just be delayed, because that polar lobe looks like it means business for us right there. If that low gets down and takes the right track, there's a lot of Arctic air behind that. I mean, look at this surface gradient through British Columbia. That is extremely intense. You've got a 992 low with a 1044 high here and a 1057 main high up here. That's an extreme pressure gradient there. So that could be some interest. That could be interesting here into the future. So yeah, Death Metal 07 said Arctic air gets pretty close at the end of the CMC run. Yeah, it does. I mean, that's, if you like cold, that's a nice signal showing this lobe up here move around. Doesn't mean it's going to necessarily get us for sure here. We'll see how this develops, but that's promising. That's a pretty good lobe of cold air there. Well, the ridge is still out there. You can see the ridge here on the surface map of the Canadian model here, and it's steering this cold air down. So let's compare this to what the GFS is showing. Let me see if I can just bring it here. I think we can. Let's let it load up for a minute. Sometimes it just needs to load. Oh. We'll start that over again here. I think the site is having a little bit of problem. I might be slowing it down a bit. Let's try this one. Okay, so let's go over this one here. I can just show you the ridge. But for some reason, the Canadian does not want to show up here. But we'll just look at this to show the ridge. Somebody asked the question about the ridge. So there's the ridge finally starting to break down. Here comes a system that's finally going to get in here at the end of January. And you can see this bit of a polar lobe moving down towards us here. And it takes a nice enough track where this could bring some nice convergence zone bounds, like I said, and some cooler air loft. Maybe if we get some convection, you might get low snow levels with that. Plenty of mountain snow, of course. And here's the ridge kind of steering that cooler air into the region here. And as we keep going, there's the next polar lobe here swinging down into our area. So that, you know, that's kind of interesting. If we get this a little further south, then we're in business. Right there is still, this could even be a windstorm or really, you know, some nice mountain snows with this. But if that goes a little bit further south, then we'd be in business as far as snowfall. Yeah, because this, you can see the surface low in here with just really a powerful gradient behind it and a really powerful Arctic high over the Yukon there. So that is, I mean, this is worth watching. That, it gets your attention when you see these kind of, you know, Arctic gradients going on. On the ridge is the warm temps. Well, not necessarily mild, but it is a ridge. So yes, it's not, you know, this is not an active storm going on here where you see these ridges of high pressure. There is a low underneath and undercutting this ridge here, as you can see in the extended there. But yeah, generally warmer at 18,000 feet, yes. What date is the second system? So this low here is moving in. You can see that surface low just a little bit north. I mean, that brings its powerful pressure gradient actually across the Puget Sound. That would be a decent windstorm there. These are what, 2 millibars. So you're going 2, 4, 6, 8, 10. Yeah, that's a pretty vicious windstorm through the Puget Sound here and down through the Willamette Valley a bit. But if that low is a bit further south, then you're talking about Arctic air getting into the lowlands, possibly behind it. But this is on the night of the 2nd and the 3rd of February. Yeah, this would be an interesting storm system. I mean, you have convergent bands behind this, some very cold air coming in behind it. You'd have good snows in the eastern portions and plenty of mountain snow, maybe some convection. So one interesting way to look at this too is yeah, I don't know what's going on here with this. The site is not responding well. Let's look at the CMC here. It works there, but it doesn't want to work on the other ones. Okay, let's try this. Let's go. Yeah, looking at the North Pole, these polar lobes are something else. There's the East Coast storm here. If you can see this continental U.S. right there. There's the East Coast storm there as it swings up. A very powerful storm. That thing is dropping. I think was it the European this morning had that system dropping 50 millibars in just under 24 hours. So a great case of a bomb cyclone there. And there comes our system there on the 31st. And then you see the next polar lobe swinging around. Stays a little bit too far north to bring really good cold air into western portions of the states. But it is close enough for you. You need to watch that. And that could bring other problems too, like windstorms. Yeah, no problem, Sam. Yeah, I mean, working for a major airline, you get a lot of practice forecasting, and I work with these maps all the time, and it's something that you get pretty good at after a while. I mean, everybody misses forecasts. It looked like it was a little bit more promising earlier on the Arctic air getting down towards us, but it was never to a point where I was ready to say, okay, this is going to happen. It's not fantasy. So there's still a chance of it, though. You can see that ridge set up out here. If this ridge is a little bit further off to the west and allows one of these lobes to get south of us, we could get a nice snowstorm through the lowlands here. Do I ever watch for stratospheric warming events? Yes, I do, but there is a big lag time between stratospheric warming events. You'll get them, and then you can get lag time of weeks after, and they're still not that well understood on how they affect sensible weather at the surface. So there's some uncertainty with it, but they are fascinating. Here, let's look at. So this is the stratosphere. Let's see if we can spot any kind of stratospheric warming here. Let's go all the way back. This is the 0Z GFS. And you can kind of see the polar lobe is a little bit extended towards the east coast, and that's kind of why they're getting that storm. But you can see that it's hard to pick up. That's kind of subtle. It's just kind of reached out towards the east coast there, and then you'll see it retract, and it's back over the North Pole. And then you see kind of a split going on here in the polar vortex. This is looking way up in the stratosphere too. This is like in the upper levels of the atmosphere. But this is kind of like a stratospheric warming event here. See this ridge kind of punching into the polar vortex here? And you've almost got a split here. The main lobe is here, and you've almost got a split out towards Europe there. And then there's a big one there. Check out this huge ridging over Europe there. That's nuts. I mean, check this out. That thing extends way up past. I mean, that's incredible. That thing goes way up into Russia there. And you can see that's what they call a split. When the polar vortex splits, that's what they mean right here. And this thing was the vortex was reaching out much more to the Pacific Northwest a bit into early February, but it's kind of taken that away now. It kind of had it there and extending more down towards us. And now it goes back out towards the East Coast a bit more. But that can always change back. I mean, and plus the lag time with the polar vortex is so, it doesn't directly correlate to surface temperature. Jonathan Pulley says flying in from Oklahoma was a bit sketchy with all the fog over SeaTac yesterday. Yeah, we're in the soup down here. Back in the day, before we had the Cat 3 approaches, we would have huge problems. You'd have a lot of flights get canceled and just missed approaches. You'd have big diversions. And nowadays with the Category 3, you can land in really low visibility fog. Can cold weather systems bring lowland snow without true Arctic air from BC? Yes, they can. You're talking where you have to get really a good setup with, it has to be a powerful front with good cold air aloft, and you have to have the precipitation rates have to be really strong, and you have to be able to drag that cold air down to the surface. And that system will also have some kind of Arctic or polar origination too. It's not like you're just going to have tropical moisture come up and get a big snowfall without some kind of Arctic air around. Yeah, Pacific Northwest weather lover. There was some fog all day in Puget Sound. Yes, there was. Did not break out again today. So Mark Bass asked about the 5G radar altimeter situation, and for example, the airlines have alternate methods of compliance, and so everything is okay right now. Um, we're not airlines aren't canceling flights. There's no issues. Everybody's making it in. Everything's safe, and there's just no issues right now. But that could change later. I guess I don't know exactly just how much the 5G is going to affect things if they're going to turn it on fully later. But they should wait till summer to do that, just so it's not interfering with low visibility landings and whatnot. And that's what they're doing. So it's not an issue right now. Pacific North American oscillation. Yeah, let's take a look at that. We'll go to here and we'll go. Let's see what because that was kind of leading us down the path there, and now I wouldn't be surprised to see that kind of changed a bit. Now you can see how the European is it brought it down negative, but it's not really some of those negative values that we had for a couple weeks in a row. It was pretty strong signal, and now it's not showing that too much there. The extended, I don't know. I mean, it still shows it here into the first, and things can still change. We're still a week away from even that first system coming in here. So things are still going to change quite a bit. And by February 3rd, we could very well be looking at Arctic air back into the region. There's nothing saying that we're just like done with Arctic air for the rest of the year. It's just always a tough task getting Arctic air in here. So May and S is saying that 5G rollout was delayed at big airports like SeaTac, but no commercial flights left Payne today. Yesterday, as far as I know, because it's NOTAM for 5G issues. Yeah, I can't speak on it too much because I could get in trouble at work if I'm talking for the airline or anything. But I was not aware that. I mean, we can look at. Well, I'm not even going to bring the NOTAMs up, actually, because I can't speak for the airline as far as what's going on with the 5G NOTAM, but I know that safety is not an issue is basically the thing, and I know that there's not a big, massive amount of canceled flights. How accurate is the PNA? Well, it's just an oscillation, and it's really not that accurate. It's just one of the many tools we have to try to predict what kind of pattern is coming up in the future. So basically, we take weather pattern. We take what happens during previous Pacific North American oscillations, and we try to put that into forecast into the extended. Like if we know that when it goes into negative, we tend to get ridging over the Pacific Ocean. Temperatures tend to be a little bit cooler, but it doesn't always mean that's the case. So it's just a tool. I mean, even in La Nina years, we have warm periods. Even in El Nino years, we have times where it's, we can get snowfall. Yeah, Arctic air. So Pacific Northwest lover says Arctic air has trouble coming in, but then it has trouble trying to leave the Pacific Northwest. Yeah, that last one was pretty good. I mean, we had below freezing temperatures for 5 out of the 6 days at SeaTac. The European is going to start running here pretty soon too. So here, let's see if I take some of these down, if it helps us out here. Yeah, here's the GOES 17 satellite. I mean, the Puget Sound is just locked in, except for the higher terrain. You can see it all the way up in the valleys. Didn't really burn off much today, did it? Well, it looks like Portland's kind of cleared out a bit. Those, I mean, a little bit of east wind clearing them out a little bit, it looks like. It depends. I think the European will probably be done running about 10:30. Maybe I'll try to stay on that long. We'll see. But you can see like the European this morning run really took the snowfall totals down, and the temperatures also. There's a few members in here that had some Arctic air into the region. 1, 2, 3, 4, 5, 6, maybe 7 out of 50. Not very good odds, and it means that's probably not going to happen. Salem socked in for the last few days. Yeah, let's look at the GFS extended, the GEFS. So let's look at that. And we'll take a look at North America. And let's look at the upper level heights first. So here we are now. The Death Ridge will not let us break out of the fog here in the Puget Sound. Ridge finally relaxes, and there goes that East Coast storm out there. And here comes that next system sliding down. So this might be like I said before, this might be a fun system. There's some cape with this. There's going to be cold air aloft. There's going to be surface winds interacting with terrain. Like it's convergent zones. We might tap some of that cold air aloft. Could get a couple lightning strikes out of it, some small hail, maybe some, you know, that can bring snow down to the surface briefly, but it's not a big Arctic blast. We're not going to get a bunch of frozen sidewalks and all that good stuff. And then you can see just the huge trough setting up over the west, and the ridging for the east according to the extended GFS here. So this, you can see how the ensembles, as you get further out, it kind of smooths this out. So it's not telling you that much. It's not telling you where these individual lobes are moving down. And that's because it's just hard to do. I mean, even if you're looking at operational run and you're trying to pick out individual polar lobes moving down, and it's like, you know, it's like chasing butterflies. It's going to change, and it's going to change from run to run. Yeah, the ensembles are good for giving, you know, general patterns and whatnot, but they're not always that useful as far as getting Arctic air into the region. And telling you those odds sometimes is kind of tough. Where it is good is when you're looking at like this. The European runs 50 of these individual ensemble runs. And you can see, you kind of can peg the odds, and you're like, okay, it's probably not going to get Arctic air in here. So it's good for that probability aspect of it. But you need to look at these versus just looking at like this and just saying, okay, so this is going to happen. You know, you want to be able to, you know, if you're planning for a business or if you're forecasting for an airline, you want to be able to come up with some details and try to figure out what exactly is going to happen versus just giving broad brush forecasts. I mean, Glenn asks, with Arctic air moving out of the Fraser River, how often does it bring lake effect snow over the island waters of the San Juan Islands to Port Angeles? Well, really, anytime it occurs, it will bring that on the right trajectory. That's a lot of cold air, and then a relatively warm Puget Sound, it crosses over, picks up some of that warm air, and then it hits the Olympic Mountains there, and it forces that up. And when you force air up, of course, it cools and condenses, and you get some pretty good snowfall totals over there in Port Angeles when that happens. So yeah, it's common when you get those outflow winds through the Fraser River Valley. Yeah, I love the big Arctic blast too. Kevin Moore wants the big Arctic blast. Yeah, I mean, they are fun. It's not fun when you're at work or you're trying to do something that requires you getting around in the snow, but What is most dangerous weather for the airplanes? Well, I mean, as far as airplanes go, I mean, landing, takeoff and landing are the most dangerous. So you just want to make sure that you've got a good idea of how the runways are. So it's probably ice and things like that on the runways. But aviation is extremely conservative. So anything we do when we calculate like runway length, takeoff, we always add these huge buffers to it. And then we put buffers on top of buffers because, you know, everybody wants to be safe. And the US, the FAA and flying in the United States is extremely safe. It's really, it's thousands of times more safe than it is to drive a car across the US versus just flying across the US. And so there's all kinds of buffers. The technology is really good. The pilots are really good. You have dispatchers watching every aspect of the flight as well. And the mechanics are great. So yeah, but yeah, when you're looking at trying to land in a snowstorm or things like that, or when you've got ice on runways and stuff like that, those are pretty, those are the most high risk times, even though they are still safe. Yeah, Michael Pitt talked about altimeter setting being too low. Yeah, it's things like that where we have all kinds of built-in, you know, because back in the day, airplanes didn't have like ground proximity warning sensors, for example, and now, you're flying around in a big jet, and you can be totally blind, and the sensors are going to tell you exactly where you are if terrain is nearby. There's so many safety features built in that it's just amazing. So Robbie said, I thought La Nina patterns have colder weather, not warmer weather. It's strange weather this winter. Yeah, I mean, we had a really cold December, and that's usually kind of how La Ninas work. You get a stretch of really cold weather, then you kind of get the normal period for a while, the ups and downs of winter. And, we could easily see another snowfall in February for sure. Thunderstorms are also dangerous for airplanes too. Yes, absolutely. But again, like back in the 80s, there were some crashes by some major airlines, and since then they've put like wind shear warning systems at the airports, and now there's really good wind shear warning systems on the planes, and there's really good Doppler radars on the planes. And for example, if you're trying to land and there's a thunderstorm nearby, you're not even allowed to. You just go around. You've got plenty of fuel. You go around and you wait till things are safe and you come back in, or you go to an alternate airport. So that's why those crashes just don't happen anymore. Aviation is just so much safer than it used to be, and it's by far the safest method of travel. I'm a bus driver in Portland, and so I hope for the Arctic blast. Yeah, I mean, looks like an Arctic blast is not in the cards right now, but it could still change. That definitely can still change. Yeah, no problem. Thanks, Kevin Moore. So let's look at. Let's see. Let's see if the European is starting to run yet. Not quite. I think it's a couple more minutes. Yeah, the 70s and 80s, the aviation was becoming safer, but it was still, anything is inherently dangerous, really. I mean, if you think about it, what is it? I think it's 100 people a day approximately die in car crashes just in the United States. So you can imagine, and it's, in being in aviation, we hardly have any deaths over the period of an entire year. So it's just kind of like an accepted social norm that we kind of just say a certain amount of people are going to die in car crashes each year. Have you heard about flights above the Pacific Northwest? I'm not sure what that means. Robbie says, I've seen a snow march in a few times. Yeah, we had a really good snowfall in '89 in Seattle. there were some places with over a foot of snow right next to Seattle on March 1st. You can get snow all the way into actually mid-April even, but it's generally your chances start going way down after December or February. Jonathan Pulley, thanks for stopping by. Pacific Northwest weather lover, yes. Oh, that's right. I made you a moderator. That's why you have that wrench there. That's cool. Wait for the 0Z European model to come on here, and we can watch that come in. It's 35 degrees outside of my house right now. I'm not even sure what the high temperature was today. Let me check that out. Got to 39 at my house today. And we had that's some pretty dirty air going around here. You can see it's calling a moderate air quality level right now. And it's getting a bit stagnant out there for sure. You can see the wind rose, just light winds out of the northeast. Sunrise tomorrow, today was 7:45, so about the same tomorrow. Oh, so that's a positive rate. Media says it's a community of 14,500 local pilots could definitely benefit from briefings. Yeah, I mean that's kind of what I do for Alaska Airlines. That's my day job. Are those private pilots and instructors, private rate media? Yeah, if you want to send me a private message on Twitter, Seattle Weather Guy, or if there's a way to do it on YouTube, you can always just message me there too, and I can get you my email or whatnot too. All right, thanks for stopping by. Whoever's heading out now, we're going to start the European model up here pretty soon. Okay, so I'm going to cut back on some of these here because I think I'm overloading the weather bell page. See if I can get this to move too while we're waiting. Yeah, send me a DM on Twitter. That'll work. This is the GFS. We were looking at the polar vortex earlier for those of you just joining. It's kind of backed off on its march towards the Pacific Northwest. That could change again, though. We're still quite a bit of ways out before this pattern change is going to come. And we'll take a look here at the... I think it just starts running now. Yep. Thanks for stopping by, guys. All right, so let's go over the GFS one more time since we're still waiting for the European here. Let's look at what the GFS is bringing. Actually, first of all, let's look at I want to spend just a minute here on the East Coast storm too. This is a really dynamic storm. It looks like it's coming. So you're probably going to be hearing a lot about this coming up here. So here we're at, this is Friday right here, Friday morning. You can kind of see it developing here. So if we're looking here, you can see this is like an open wave, maybe 10, let's call it 10 millibars here at 0Z on the 29th. And in 15 hours, it drops 31 millibars there. That's an extreme example of a bomb cyclone. And it's a 965 millibar low there by the same time. So what is that? That's 1035. That's 45 millibars in 24 hours. What an impressive storm. And it brings some pretty decent snow. It looks all the way up the coast. Not quite as heavy as the European is showing now, I think, though. There's some Heavy snow bands close to the coastline here. It looks like it gets Boston pretty good. Cape Cod as it moves by there. What a storm. But then anyway, here we go for our next system here. And this is the 30th. You can kind of see the system pretty weak, but it's got a nice trajectory where it might bring some convergent zone activity off Vancouver Island, off the Olympic Mountains as it passes through. And there was some convective available potential energy there too. It might get a thunderstorm or two out of it. We'll have to see how that develops. And the Arctic high is still parked pretty far up there. Not a very strong gradient through British Columbia. So we're not expecting an Arctic outbreak as of now. And look at this storm kind of right up through the Midwest there, through eastern Canada. And then the next system there later in the time period, still mostly east of the Rockies there. So the GFS 0Z didn't look good. The Canadian one looked better. Let's play the Canadian one out too while we're waiting for the European to come up. Yeah, thanks for you guys, whoever, all you guys that have become members. That really helps me be able to maintain the page also too. So thanks for that support. And here we go. Here's our system that moves down. It's a pretty weak system. It's kind of falling apart by the time it gets here too, but it's going to bring some really good mountain snows, pretty strong onshore flow, some chilly air aloft, a little bit of convection involved, so we might get a thunderstorm out of that. And then you can see this next storm, a pretty powerful storm that dives in here, and a strong gradient that goes across the Puget Sound here, and this low swings through. It's got some cold air behind it. Really stout gradient through British Columbia. So there's going to be areas in British Columbia that get some nice Arctic air out of this. And a really powerful Arctic high on the Canadian, if the Canadian model here is correct. But yeah, this would just be a huge, prolific snow in the mountains here for the Cascades. Peter Motley says, I feel we're due for a significant wind event. What do you think? Yeah, I mean, this is a signature for it right here. A storm taking this track, that's a perfect north-south gradient. That's when the best winds line up through the Puget Sound, and that would be a pretty strong blast there. Maybe we'll zoom in a bit on that, just to take a look at what those winds would be showing here. Probably somewhere in the 40s for the Puget Sound. Surface wind, wind gust, swath. Yeah, 38. Well, there's some 40s up here too, but you can see that gradient though through eastern Washington. That might be a pretty wicked storm for eastern Washington. There's some powerful winds over there, and it looked like that was didn't bring much snow to, but there might still be snow on the ground over there when that system moves through, and it might get some blowing snow. But you can see huge snow totals in the mountains, which we can also look at closer here. So we've been really damaging the snowpack with this inversion and these sunny days up there, but the Canadian building it back up pretty good again. I'm sure the GFS probably has some good totals there too. Not bad. The Germany model. This model does not seem to be very reliable. It's called the Icon. It's a Germany model, and it does not seem to perform near as well as even the GFS, the Canadian. Yeah, Miami red zone. You think Seattle weather is boring? Miami weather is non-existent. Debbie Nelson asked, do you remember the huge windstorm on Thanksgiving in 1983? I do remember that. Remember my mom trying to cook the turkey and the power was out, and it just kind of ruined the whole dinner there. I don't recall if we got the power back on, but I can remember it going out and my mom being unhappy with the turkey sitting there with no power. And can we look at individual GFS members? Yes, we can. So let's take a look at that. We'll go. So what you do is you go to this and you click GFS here and switch members. And let's see, you got to make sure. So 00Z, and it kind of updates as it goes. So this is the master run. Then you can kind of go through these individual ensemble members here. And I'm gonna bring this all the way out to the 31st and kind of see what this storm looks like. So this is our next system. It's in front of this Arctic air mass to the north, but it's generally pretty weak, and it precedes it by a great deal. So it's not going to be a big snowmaker for the lowlands. I mean, but some of this doesn't look bad. I mean, like this is a GFS ensemble run here. So this is one of the runs that has had the initial conditions tweaked a little bit and then allowed the model to just run out. But this isn't a bad setup here. I mean, that's getting close to being a snowy solution there for Western Washington all the way down towards Portland here. That's a very powerful Arctic gradient here. So you can see some of these individual runs still show the possibility. It's just that most of them don't. Yeah, power was out for 2 days. That was a crazy storm. Yeah, tomorrow looks like we're going to be still around 40 degrees for the Puget Sound anyway. Or if you're in the fog in the Willamette Valley, you're probably going to be, low 40s also. So the GFS, this last run, did not bring Arctic air into the region. But now I'm playing this individual run here, and you can kind of see that Arctic air is into the region here on this run. If we change parameters here, yeah, this is a very cold solution on this individual run. And if you look here, we've got 30 individual members. So now watch, when I click number 2, look how much different that is. Arctic air definitely well up into British Columbia. Let's click number 3. This is another cold solution there too. So that, you can't completely rule out Arctic air. Now let's go to 4. That's another chilly solution here, but a little bit further north, maybe a hair too far north. That's, these first 4 of these first 5 actually brought some pretty cold air pretty close to the region here. And again, number 6, not bad. There we go. So 5 of the first 6 were pretty cold. Now you see number 7 here. Look at, there's no Arctic air anywhere nearby. We're looking at, so Debbie Nelson says she doesn't understand these solutions. This is the temperatures at 5,000 feet. So you need about -6 or below that to get snow down into the areas of Western Washington and Oregon. And as you can see, like in ensemble member number 6, there was some pretty good cold air just north of us. So there's 30 different solutions of this. When the GFS runs, it runs 30 different solutions on top of its control run. The control run takes the initial conditions as we believe them to be, and it runs the model out. And then you've got 30 other solutions that you'll tweak those initial conditions to try to account for our errors, and then you let those model runs out. And you can get some wildly different solutions. Like when you're looking at 6 here, if I click on 7, look at how much difference there is between these 2 model runs. The air at 5,000 feet is completely different. And then you go to number 8, some very cold Arctic air back behind the Rockies, but that's not really a big threat to us here in the lowlands in Western Washington, maybe more in Eastern Washington, but not for us. Then we look here, that's a fairly chilly solution there too. Number 10, again, cold air is in the region. It's over BC. A little bit further north there. And then you can kind of see how far this extends down. But yeah, as you can see, there's chilly solutions in these individual ensemble runs. And the Arctic air isn't that far away in a lot of these. Can it be negative? Well, this is at 5,000 feet too. Remember, guys, this is at 5,000 feet. So you need about -6 Celsius at 5,000 feet to get snow down to the surface. So if we look here, like ensemble run number 13, very cold. 14 very cold. But then here 15, look at no Arctic air in sight, well north. 16, that's another, it's close. So there's going to be cold air that passes by us, but it just doesn't look like it's going to take the correct trajectory to get into the lowlands yet. There's a lot of cold air up there. Especially some of these runs are kind of wacky. But as you can see, some of these are pretty relatively warm also. You can see that true cold Arctic air bottled up north. This is getting a little bit closer here. Yeah, this run right here at 22. There's some really cold air getting to the region here. That would be Arctic air into our region there. Yeah, Jeremy Williams says operational's been bad for cold. Yeah, the operational was terrible this round. And like you can see, some of these individual runs have cold air pretty close. Yeah, Chris wants 15 feet of snow, but that's probably not going to happen. Maybe if you live up at, yeah, if you live way up in the Cascades, maybe. Yeah, I'm kind of surprised actually at how many of these ensemble runs have really cold Arctic air very close. So that's also one of the caveats of looking at just the operational run. Sometimes you miss the operational run, can be out in left field sometimes, and that's why the ensembles are important to look at also. This run doesn't have much. It keeps it mostly east, but and these runs are keeping the Arctic air well out of the area here. That 29 is pretty chilly. Something else you can do here too. Let's do this. So if we look at these, we'll go to the GFS and we'll look at Seattle. Or we could look at any, well, if it's going to load here. And we can look at 500 millibar height here. So we'll look at this. I don't know what the next winter storm name is. That's something the Weather Channel usually keeps track of pretty well, but I'm not sure. So something I'll look at here is, look, you can see 520 millibar, 500 millibar heights here. So right here on this is the third, about 0Z. Let's go look at those. Let's look at the third. At about 0Z, which is right there. And then we'll switch the parameters here to 500 millibars. Now let's see if we can find that one that had the lowest millibar value for us. You can see we got a low of colder air aloft moving over us here on this run, and we look at that. That's member number 30. And once I see a promising look here, I'll stop. Like this is something you'd want to see here, and you'd want this to kind of track right over us. And this is another interesting lobe here, depending on how it progressed through the area. Nothing there. Nothing there, a big ridge. Now we're looking at a more zonal flow here. As you can see, most of that polar lobe moves out over here, and this would really start to develop storms out over the Gulf of Alaska and keep us warmer. Maybe an atmospheric river, maybe a windstorm. And this looks like a lobe kind of passed by us, but not that cold, not true Arctic. This would be good if this progressed over us and down south. Which, yeah, this would be an interesting track there. That would be fairly interesting. This is the good trajectory there, but I digress. Let's go back a little bit here. We're looking for that really low, and we're probably going to get it in these first runs that were really cold. That would be a nice one here too. That'd be a good trajectory as this thing progressed through the area. Pretty chilly there. Oh, we skipped 9. Let's look at 9. 8, 7, 6. I guess we did not spot the correct one. Maybe it was one of those that we looked at earlier. But you can see all those different solutions. We had some good lobes of polar air getting near us, and we had some ones that were pretty ridgy, like this, the master run here, just showing a big ridge versus. I mean, look at some of the differences between these ensemble runs, and this just kind of shows you, the variability and how difficult it is to forecast this far out. This is a full, 11 days out at this point. All right, let's see if the European model is running now. There it goes. We're already out to 48 hours. So let's start with the heights. And we'll just kind of load that in. See if there's any big changes right off the bat here. Here's the big death ridge over us right now. Fog Ridge 2022. And so here comes that East Coast storm here. This was the system originally. The European was actually wrong on this one. It had this system breaking down the ridge and bringing us precip about on the 28th or 29th, and it's taken that away also. So the European is not perfect either. So we'll wait for this to load a little bit more here. So yeah, as we saw here, there's some pretty different individual ensemble runs here. Let's scroll back through these again. This might have been the one that brought those extreme. Yeah, this was the one here that had the sub 520. Yeah, Miami Red Zone talking about when I was in Washington, we had a weird hurricane-like storm, and it was windy with little rain sometimes in November. Yeah, we get those windstorms that don't bring much rain sometimes, and it brings some pretty good winds through the area, especially in November. Yeah, every once in a while we get a severe thunderstorm warning here, but it's pretty rare. I think May 2017 is the last one I remember. I think that was just south of us near Olympia, actually, too. Had some gorgeous thunderstorm activity. We had 4 rounds of thunderstorms move through that day, May 2017. November of 96. Yeah, pretty much every year, November, December, we get some decent windstorm at some point. We get good windstorms all the way usually through March. Yeah, that May 2017, that was a fun one. This would be a really nice setup here, too. Let's look at Yeah, I mean, that's a powerful Arctic high there. Check out that gradient. That's impressive. So if we zoom in on that, we can, this is how they measure the power of these Fraser River outflow events. There's a place called Lake Williams up here. It's right about here where this 1026 millibar line goes over. And we have the 1005 millibar line here. It's about 1004, maybe 1003 at Bellingham. So 26 minus 3, 23 millibars. That's a pretty strong Arctic blast through the Fraser River Gap there. And that would probably be bringing some upslope flow into the Olympic Mountains there. That was what we were speaking about earlier. Yeah, I remember that September 2020 storm too. We get good thunderstorms here once in a while. So Sean O asks about being on Whidbey Island. He asked to describe a bit about what causes the most extreme winds, best way to forecast it, learning a lot from how you read pressure gradients. So what happens with our strongest, should I show this map here? Let's just show this map here. I wish I could just find one with powerful gradients on it. Do I have one somewhere? Let's see. I could do this. Let's do this. We'll do Western Washington, and we're going to go to, let's look at the inaugural day storm. Was anybody here for the inaugural day storm? Anybody remember that beast? So I'm going to talk about, Sean O is asking a question about Whidbey Island and what brings the powerful winds, and I'll show you exactly what brings those winds. So let's find our parameters. Let's go sea level pressure. And this is the day before. And here comes the inaugural day storm. This is one of the strongest storms to ever strike the Pacific Northwest. I mean, this killed people, that brought down a lot of trees, did huge amounts of property damage. Now, if you take a look at this closely, you see this 976 millibar low, and you look at these gradients on the south side of that. When you get gradients packed in like this, you can get extreme winds. And some of the greatest storms ever have been about 15 or 16 millibar pressure gradient between Seattle and Portland. And you can see that 976 to 996, 20 millibars there. If you throw that gradient over a small area, it's an extreme pressure difference. So if we go forward one more step, so look at this gradient that's coming for the coast of Oregon here. In fact, let's zoom in on that. You can see Astoria there, but you've got 978 to 979. You're casting a 19 millibar gradient across that. You're probably looking at some very extreme winds. So let's look at, I believe they only had mean wind speed, but you'll be able to get the gist of it there. Very powerful winds. In the tighter the gradient, the more powerful the winds. So when we back out a bit more here and we go forward, and we'll back out a bit more so we can see the full low. So when these low pressures move right over the interior here, like over the San Juans, over the southern tip of Vancouver Island, over the northern tip of the Olympic Peninsula, and they track right through here with that strong pressure gradient on the south side of the low, that's when Whidbey Island really gets hammered. Another way that Whidbey Island can get it really bad too is you get a strong low up here, and you'll get a real powerful southerly gradient out ahead of it too, or what we call a southeast sucker, when you get a really strong low even a little bit further out and you're casting powerful gradients, and the southeast wind aligns with the terrain through the Puget Sound here as you go up through the San Juans into the strait. So it's this very strong pressure gradient. So if you're looking for that on a model, one of these modeled maps, we can look at the Canadian actually had a decent pressure gradient. We can actually look at that a little bit closer here. Oops, did I do? Here we go. And we're going to look at the European. The European is running right now, so stand by, you guys. Oh, I bet I went in too far. Sorry, we're going to have to back out one more step here, and we'll look at surface pressure. And as they bring that system, I think it was on the 3rd. There it is. So you can see this one, this storm system moving through here, this will bring decent winds through the Puget Sound. It's about an 8 millibar gradient, almost 8 from Seattle to Portland, which typically brings 40, 45 mile per hour gusts. It can bring nuisance power outages, down some weakened trees, or maybe take down some branches. But you can see the gradient is pretty good on the south side. But this isn't a huge monster storm. It just gives you the general idea. Look on the south side of these storms. When you have the low pressure track just north of your area and the gradient's tight on the south side, that's when you know you're going to get hammered. Do you think we'll get a good snowstorm in central Washington around Moses Lake area? Well, this looked like it came in pretty dry for mostly mountain snow, like in a system like this. But you have the chance here in the next couple of weeks, especially after January 30th, as these systems start moving through, you could get snow in eastern Washington, sure. Yeah, no problem. Marie Spencer asks, says, I remember the Columbus Day storm. We stayed at my grandma's. We had large Douglas firs near our house. My mom remembers that storm too. I kind of wish I was alive for that one. I'm jealous. Okay, we were out to hour 75. So let's see how the European is doing at hour 75 versus its 18Z run. We're looking at the late morning versus afternoon runs here. Not many differences, really. You can see the system down south here is a little bit weaker still. System here, ridge basically the same, a little bit stronger. The system out here a little bit stronger. Not many differences yet. So I've noticed the European from run to run is usually a little bit more consistent and steadfast versus the GFS. I don't know if that's by design or what, but the European did take a big swing this morning. I mean, it changed quite a bit. It really cut off Arctic air getting into the region. Yeah, Death Metal 07 talks about the 2006, the Hanukkah Eve storm. That was a monster. 69 miles per hour at SeaTac. That brought down a lot of trees. Pacific Northwest lover is looking at NOAA to see if you can find that day of the big thunder. I think that was I want to say May 5th, 2017, if that's the one you're talking about. So we're letting the European model load up here. So what other, somebody else name a storm in the past and we'll look it up. What storm do you guys want to see? You can see this is the inaugural day storm here. That just incredible pressure gradient. One of the strongest ever from Seattle to Portland. If nobody says anything, I'm going to do the 19... The 5, is that the thunderstorm you're talking about there? So we're looking at surface pressure gradient here. We're going to look at the 1981 superstorm. Blizzard of 96, that was good. Okay, we'll do the 1981 storm here, then we'll do 96, and we'll do Columbus Day storm. So here comes, look at this intense storm. November 14th, 1981. I can remember this storm too. I mean, I can, it'd be pretty crazy. I think this is actually, and we had back-to-back storms too. But yeah, this is a really intense system. I'd like to see just how crazy the weather community went around the Pacific, would go around the Pacific Northwest if a storm like this hit today. So let's do 1979. Yeah, let's look at that one, February 6th. That's the one the Hood Canal Bridge sunk. So we'll start on the 5th. This was actually a lee low formed in the wake of the Olympic Mountains on this storm. That's why. So it was actually more of a mesoscale process. Very powerful winds moving over the Olympics like water would in a river. As it goes up and then gets forced down, it heats, and that heating forms this lee low, this mesoscale low that packs a really powerful pressure gradient in there. So as you can see, the storm was well far to the north. But it's the flow moving over the Olympics so fast that caused the damage. Mesoscale low. And I don't even know if that would even pick it up. And you can see a little wrinkle in the surface pressure map here, but it's not picking it up too much. How's Hunga Tunga doing? I mean, that pressure wave bounced around quite a bit. It went. I saw some reports saying it went around the planet like 10 plus times. Okay, let's back out and we'll look at the Columbus Day storm here next. Yeah, no her back in the day, that's for sure. So we'll start the day before here. And look at the storm that came up the day before. Just an intense monster in of itself, but just kind of got lost in the complete insanity that was about to ensue. And this is why the Columbus storm was such a unique outlier and potentially a 1 in 500, 1 in 200, 1 in 1,000 year event. Look at the development. That's a 3-hour period from 75 to 56. And then off the Washington coast there. Just an insane system. Oop. But yeah, that's the Columbus Day storm was so close to the coastline. That's why it did so much damage. You know, it killed tens of people. It actually destroyed parts of a zoo in Tacoma, and a bunch of animals escaped. Just unprecedented damage, like many homes, huge blowdowns in the forests, huge amounts of timber blown down. May 30th, 2020. Okay, what's May 30th, 2020? Let's take a look at that. Are you talking about, is it the thunderstorm here? Yeah, Death Metal says the stuff you see. Yeah, the Columbus Day storm is something that you saw in the 384-hour GFS, and it came true. Miami red zone. Yes, the Alaskan coast gets huge storms up there. Yeah, so we're on May 20th here. Oh, so this was that. Was this the slight risk or the enhanced risk over there in Eastern Washington Day? I was over there chasing that stuff. Yeah, there's a lot of cape around. So what atmospheric setup causes such a pressure drop just off our coast? So you're getting a really sharp combination of really cold air versus really warm air. It's a temperature gradient that's happening. So if we back out, let's go back to the Columbus Day storm briefly here. And that storm had tropical origins too. So there was a cold upper level low, and there was, you know, a lot of tropical moisture with it. So the oceans are pretty warm as far as, you know, in October. There's still tropical storms out over the oceans, and it was Hurricane Frida, and it that energy moved across the Pacific pretty rapidly at low latitudes, and it got over here and it merged with this upper level trough and just exploded the Columbus Day storm onto the west coast. So let's take a look at. So you can see the first storm here. Very cold air aloft for October also. And then you match that with basically the old remnants of a hurricane. And you can kind of see that first storm move up the coast there. A very powerful storm in its own right, but it stayed off the coast as most storms do. And now here comes the Columbus Day storm. So just this incredible pressure gradient. At 18,000 feet, you've got a lot of, I mean, look at how much, there's some really warm air and some really cold air behind it. So just an extreme pressure gradient moving through with that system. And if we look at temperature at 700 millibars, it'll probably show up well here too. We can see just the extent all the way down to California. Some really cold air just dove down and brought this mid-latitude cyclone back up over us. Let's check out what the temperatures look like at 5,000 feet. This kind of shows just how much cold air. This is, you know, this is just, this wasn't even a month after summer technically ends. Check out the wind speeds with this thing here too. And so this jet stream formed because of just that extreme temperature gradient. I mean, look at these, some 200-kilometer winds racing up the Portland coast, or the Oregon coast there. Just incredible. What a storm. 226 kilometers. Then you look out over the coast in the center of the storm, and you're down below, you know, you're relatively calm at 18,000 feet. Yes, a ragingly intense cyclone. Oh, it was May 30th, that one was. Okay. Yeah, I remember there was a lot of cape over there. It was, but that was, yeah, it was a thunderstorm setup. All right, thanks for stopping by, Pacific Northwest Weather Lover. Yeah, there's some intense storms up there in Southeast Alaska. I mean, there's some real monsters. The Aleutians get the real powerful storms. This is recreated actual conditions. So Doty alike asks, is this past archived model data you use? This is past archived information. This is not model information. This is actually what occurred, or to our best of our knowledge anyway. All right, let's check the European. How far are we out? 135 hours. Let's look at it. See if we can start to see any differences and see what the trend is telling us here. So there goes the ridge over us now, and then that system kind of dies over Southern California, and I don't know why it's been doing this. Well, let's take it off then. And the next system's still progged to come down. So it looks like it's coming in as it said prior. This has got a pretty good overwater trajectory, so it's not going to be an Arctic outbreak or anything like that. But this system still could bring some exciting weather. We might get some convergent zone activity. There's going to be colder air aloft with it, maybe some convection, maybe a lightning strike, maybe a few lightning strikes, a lot of mountain snow. And depending on the track, well, the system does weaken as it moves in towards the area, so it's not going to be a windstorm threat. "40-year-old man that just saw snow first time last week." That's crazy. Yeah, Will Parnell says, "Thanks for the explanation. I can see why the East Coast gets those bomb storms with the warm tropical air and Arctic air in place." Yeah, exactly. Because you've got, you get one of these polar lobes to move down, and you just got this really warm water just that can feed these storms and make these really intense systems. Which reminds me, let's take a look at what this latest run is showing here for our East Coast storm. Let's zoom in. We're out too far. Okay, North America. Here we go. East Coast. Let's see. There is the storm developing here. So it's about 1,000. Let's see. We'll start at 1,008 at 21Z. So you're looking at 40 millibar drop in 24 hours. And look, the European is just punishes New York there. What a storm that would be. I mean, and it kind of stalls out there from it. It even takes like a little victory lap over Long Island. That is a pretty intense system right there. Let's look at the precipitation type with that. I mean, look at that intense snowfall there. And the winds would be really strong out of the northeast here. That's why they call them nor'easters. So as this thing creeps up the coast, it doesn't look like much there, but all of a sudden it just explodes. I mean, a 980, that's a powerful low right there. Still dropping, 971, 965, just an intense cyclone at this point. Powerful northeast winds, heavy snow. New York, New Jersey, all the way down, Baltimore, down the coast. And Boston would just be getting absolutely hammered at this point. And Long Island, that was a really powerful storm. And that's millions of people living there. So this is going to be a big headline maker. Blue skies the last 5 days, just says Jeff Mitchell. All right, thanks, Debbie Nelson. Hello from Greenwater. Blue skies last 5 days. Yep, you guys must be just above the inversion. Lucky, lucky, lucky. I'm jealous. So we're at hour 144. So it looks like our first rain comes back about the 30th, the morning of the 30th. Looks like it starts raining. And it still doesn't look like we clear up that much, though. It's not like this is a big wind maker or anything. Kind of frustrating there. We need this system to just dive down and clear us out at the surface. Well, I don't know exactly. Ryan Sell asks, how about with the 40 current active erupting volcanoes on Earth? Will that have a significant effect on the temps the next few years? I mean, active volcanoes are pretty common on the planet. And I haven't heard anything about Unga Tonga saying it was going to be a big dent in our temperatures. So I wouldn't expect a lot at this point. Hello from Chilliwack, BC. 30 degrees Fahrenheit fog patches. So you guys might get some freezing fog there. Yeah, Mount Rainier, I can imagine the last few days is probably really nice. And this hampers that melting up there. That sunshine takes its toll, and it just packs that snow, makes a lot of water content, and then it refreezes overnight. And so that's why they call it Cascade concrete. It's just thick, dense snow packed up there. So we could use some more on top of that. Well, at least the skiers could anyway. All right, we're almost there. We're getting close. Hour 156. You can see the system just kind of dies off the coast up there, and we just kind of get this onshore weak troughing flow. Let's look at what upper air temperature. Where are you? There we go. So you can see the cyclone in the 5,000 feet, 850 millibars, 5,000 feet temperatures here. Check this thing out. I mean, it's almost got a warm core on it. Actually, it does have a warm core on it. But the air on the northeast side of it is very cold. And look at that thing spins up back towards New York, Long Island. Powerful cyclone here. Wow, that's incredible. Look at the warm core on that storm. Let's look at it at 10,000 feet here. And yeah, you can still see that signature of that warm core all the way up to 10,000 feet. It's not warm, but it's relatively warm compared to this polar Arctic air mass to its west. And you see that swing back over towards Long Island. It would be an intense pressure gradient. Let's look at the upper air wind here. You can see the trough just carving out here. There goes the system here. Some really intense winds there. Looks like 117. Is this knots? That's knots. So you're looking at over 130 miles per hour there at 18,000 feet. And there goes your cyclone. Definitely more of an intense system on the European than versus the GFS. And here comes ours here too. So it's carving out a nice trough for us. So I'm hoping that we get some cold air aloft with this into the Pacific Northwest. And then we get the lower level winds interacting with the terrain of the Vancouver Island and the Olympic Mountains. And we get some converging winds in there and a little bit of convection and get some thunderstorm activity in here and clean this air out. Pete Motley. All right. See you guys later. Big windstorm, December 2007. Let's see. Brooking, Oregon, 79 today. That's wow. That's summertime. The whole West Coast extremely quiet right now. Yeah, I mean, excuse me. It looked like there was a chance for a good storm coming all the way down to California too. Almost 30-inch snow on Jersey Shore. Yeah, yeah. Let's zoom in on that, and we'll take a look at winter and total Kuchera and watch this storm just come up the coast. I mean, look at how quickly it dumps over a foot and a half of snow there. Look at Long Island. I mean, that's a 6-hour period there where it drops almost a foot of snow on Long Island. Yeah, this would be a historic storm if the European is right. And this is only, 120 hours out, so the confidence is going to be increasing with this. You can see the GFS is basically much more of a northeast, much less of snowfall down here in the mid-Atlantic. So if you're a snow lover, you're definitely team European model here. Look at the differences. There's probably going to be a sharp cutoff line, whichever model is right here. Look, the cutoff line is down here towards North Carolina versus the GFS, much further north up Massachusetts area. Will we ever see a storm like that in our lifetime here? I mean, it's possible. We've gotten them here before in the Pacific Northwest. The thing about the Pacific Northwest, if we get, let me back out a little bit and I'll show you what I mean. I mean, we've gotten 20-inch snowfalls in 24 hours here in the Pacific Northwest. It can happen. So if you get the right trajectory and you have Arctic air, you know, seeping into the lowlands, you bring out Arctic air off the coast and it can continue for a long time and keep bringing snowfall in. That's why our mountains get so much snowfall, is because anything that, you know, anything associated with any colder air aloft running into the mountains can really build up the snowpack quickly. So let's see, how far are we? But it's rare though. It's not like we get huge snowfalls all the time. Even though last February we did get almost a foot, you know, there in that day and a half. So let's see here. So yeah, this is kind of a bummer if you like cold air. I mean, you can see the Arctic high is too far north, the troughing is too far north, and this ridge is too close on this European run right now for us. But this, you know, once we look a little bit further out, it might be changing, and this can always change also. This, we're looking, you know, this is 7-8 days out right now. Yeah, Leavenworth, Washington had really good snowfall. They had a really nice setup over there. They had an east flow bringing an upslope component to eastern Washington there, Wenatchee, Leavenworth. Yeah, February 2021 was good. Probably one of the biggest snowfalls that we can get is when we have Arctic air in place, and then we bring a really moist Pacific system into the region, and we pass the low pressure center just south of whatever area you want to get snowfall on. If you bring a storm like that, you can easily go up. You can get 20 inches. If you have Arctic air in place and you bring a Pacific system into the West Coast, areas north of that low will get huge snowfall amounts. In fact, let's look at, I'll show you an example of that here. This is 1880, January 9th. And we're going to zoom way in here. And you can see the track of this. There was Arctic air in place. And this storm track came in almost directly over Portland. Seattle, light winds, 2 feet of new snow, 4 to 6 feet of snow on the ground. Accumulation weighs 52 pounds per square foot. It crushed buildings, houses all over the area. 54 inches of snow on the ground in Tacoma. Tenino, 30 inches of snow on the railroad tracks. Snow loading causes buildings to fail in Olympia. Port Townsend, 4 feet of snow over several days. So it can happen here, folks. And you can see it brought a huge windstorm on the south side of this. Like we were talking about earlier, this low would have come in with extreme pressure gradient on the south side. Perfect gale, breakers wash into White House. Violent storm, schooner dragged ashore. Structural damage, many windfalls. Portland, 60 to 7 miles per hour gusts. 500, 600 trees across the road in Beaverton, Oregon. And you can see just on the north side, though, the winds die off rapidly. Yeah, can you imagine a storm hitting like this in today's day and age? This cut off communication between Seattle and Portland for several days. There's pictures of this storm too. But yeah, if we ever get, that's why when I'm kind of a masochist when it comes to getting snowstorms, the more the better for me. So when we get Arctic air into place, I'm just like, I'm cheering for a big wet Pacific system to move in just south of me and just bring that record snowfall. I want to see it, but it's pretty disruptive. So, you know, you can't get You don't want to get too crazy with it, but I'd like to see it in my lifetime. And then we have another system here. Okay, so we bring that troughing down, and it's just not a very impressive system. Moves out of the region, but then we have another storm developing pretty good here. And this was the same one showing up on the Canadian model. So this one might bring some windstorm potential, mountain snowfall potential. But right now, the Arctic air is on hold according to these operational runs. I mean, as we saw, some of the GFS ensembles still had Arctic air possibility. So these operational runs may still be out in left field. They might be a bit wacky. So that's why we're going to have to monitor the trend. Like looking tomorrow morning, we'll check out what these models are showing. Yeah, there was a lot of roofs that collapsed. As we saw, it shows there. Like Olympia, Washington, snow loading causes buildings to fail. There was huge damage to structures in Seattle in that storm. Yeah, our climate is quite a bit different than it was in 1880, though, too. I mean, our average temperature, yearly temperature, is notably higher, so it would be hard to duplicate something like that. It would be hard to get an Arctic air mass that entrenched in our region again. We still can get good snowfalls, though. That was January 9th, 1880. And here we were looking at the Columbus Day storm, some of the 18,000 foot winds. You can see the huge cyclone offshore there. So yeah, the European is kind of... There's hour 192. So it's bringing a strong system in here. So we're still going to get at least some rainfall late January into early February, and then another system moving through a day or two later. But yeah, Arctic air, according to this operational runs, is not looking that great. Take another look at that East Coast storm there. Basically just, I mean, it looks like it just forms out of nothing. It's just boom, and there it is. And all of a sudden it's just on them in the East Coast. What a storm. So yeah, they're getting all the fun right now. But we'll get our round again here too eventually. Kevin Hendrickson. Squim, Washington. You guys see my... Here, let's see if I can... So if I look here... I see a couple people from Squim in here. So look, check out the t-shirt we just came up with this design. Well, the Northeast doesn't always do better with snow. Like our mountains get more snow than they do. But they just have, we have the terrain that kind of, these mountains are big here. Grateful Anne Murray. Thank you. Camino Island. Anne Murray. Thank you very much. We have these mountains here. So our Arctic air has to come from the polar regions here. If it comes over the Pacific, it modifies too much and doesn't bring us true Arctic air. It has to come down out of the north. So when you bring this low, dense mass of air and you're trying to bring it over big mountains, it's really hard because once it starts down on the other side of the mountains, it compresses. The air sinks and it warms and it compresses and it creates troughing. So, and the water is relatively warm out here. And so that troughing forms out here. And if it comes off in the wrong trajectory, it just brings onshore flow. And if it comes off on too much of an easterly trajectory, it's just a dry Arctic air intrusion. So it has to set up, has to be a really deep Arctic air mass, has to set up just right, and then it has to come off the shore and back into the region just perfectly to bring us our really good snowfall. So it's a tricky setup to get that good snowfall in here. All right, thanks Will Parnell for stopping by. Grateful Anne Murray, thank you very much. Yeah, you really need a nice setup. So that's why when we do get that Arctic air in here, it's just kind of sitting there and we're really cold for a few days, and then you bring a Pacific system in to the north and it just warms us up right away. It kind of feels like a waste. It'd be really nice to have one of the systems just come in right over Portland and just bring a nice snowy deformation band north of it and just really blast us with the snowfall. But not everybody likes snow. I got to remind myself of that sometimes. But again, maybe the European is a little bit different than its ensemble members, and this will change a bit. This is going to flip-flop quite a bit. This, again, is what we're looking at here is like 9 days out. But yeah, like Pickle Snout says, the lakes really help also. Because if you're out in the Great Lakes here, let's go out to the... Let's go Great Lakes. So if you're by these Great Lakes, as long as these aren't frozen, any type of cold air that moves over them, you don't need a big low pressure system or anything. All you need is cold air flowing over these lakes, and you produce nice lake effect snowfall bands over this. You're just moving cold air over relatively warm water, which causes instability at low levels. That air rises, condenses, and cools, and drops snowfall. And sometimes the pattern can persist for several days. So if I go to, like it's been going on the last few days, if you guys have been catching the videos, I'll take a look here. All these are lake snowfall bands. Traverse City gets them pretty good. You know, places like Buffalo and Erie, they get some nice, these bands can be persistent too, and they can drop quite a bit of snowfall in a short amount of time as this cold air traverses over the areas. I mean, look at some of these bands are pretty heavy right here. Some of these bands here near Traverse City here. So yeah, these Great Lakes really help out with snowfall totals. And then there usually comes a point of time during the winter where these lakes finally freeze over, and then the lakes effect snowfalls just come to an end because they lose that ability to cause that low level instability. Yeah, Big Dog mentions our river canyons like Fraser River Canyon, Columbia River Gorge play a big part in what happens in the Pacific Northwest. Yes, when we do get Arctic air nearby, you can see this is the Fraser River Valley here. Like I mentioned earlier, we measure the pressure gradient between Williams Lake and Bellingham here, and once it starts getting over about 18 millibars, 17 millibars, it starts building, you get high pressure built up here, and it starts coming through the river valleys into western Washington. And so when you get Arctic air nearby and you start moving it off over, it picks up the same way it does on the Great Lakes. It'll pick up this relatively warm ocean water, and it causes instability at lower levels, and that'll rise up and cool, condense, and it'll bring convergence zone events into western Washington, British Columbia. Great Coastal Gale of 2007. Yeah, I think that was the one down in Oregon. I forget the exact date of that one, though. Actually, it might be right here, in fact, though. If you guys ever check out this page, The Storm King by Wolf Reed, he has some really good write-ups about individual storm systems. December 1st through 3rd, 2007. Yeah, we can take a look at that really quick. And then we'll probably wrap it up here. I've been on for quite a while. Sea level pressure. Oh, what day was that again? I already forgot. December 1st. Yeah, this looks like that prolonged event. You can see the storm going up here with pretty good pressure gradients across the Washington and Oregon coast. And then you'll see the next system slide in there too. Again, looks like prolonged period of strong pressure gradient. And then finishes up with another powerful storm with more powerful gradients all the way down the Oregon coast. Yeah, that's the one that just went on and on and on for many hours. Period of 3 days. Actually, was 3 separate storms. Hurricane forced winds. So yeah, that's impressive. So yeah, the Squim people, the people from Squim in the chat, check out the page, Spreadshirt. Olympic Rain Shadow t-shirts available. Anyway, yeah, so it looks like the East Coast is in for a fun storm, and hopefully our models do another flip back towards some cooler weather coming up. We are going to have some systems move through, and there still is a chance of getting some snow here in February, but it's just a little bit of a disappointment in the rapid change of the models here the last day or so. Yeah, thanks for stopping by, Jeremy Williams. Yeah, it was almost good enough to mow the lawn on Sunday, or was it Saturday? But yeah, I'm going to sign off here, and I'll do another video tomorrow, and I will talk to you guys then. Thanks for stopping by, everybody. Yeah, Kevin Hendrickson, check out that t-shirt. Okay, I'll talk to you guys later. Thanks.